Hello my pre-calculus student. In this video we are going to solve one of the application of polar coordinate in real life. So let's begin with the following problem. An air traffic controller is tracking an airplane that at the current location 66 115 degrees, and the value of R is given in miles. So this is 66. So you think about what here, this is 66 miles. Part A, we want you to find the rectangular coordinate. So we want you convert from polar to rectangular. So this is part A. So let's begin with part A now. So we're going to go ahead and use the formulas. X equal R times cosine theta. So in this case we will substitute the radius for 66. Cosine of the angle theta is 115 degrees. Put in our calculator, it will be around, an estimate would be negative 27.9 miles. Let's go with the y. So y equal R times sine theta. So again we substitute our radius for 66 times sine of 115 degrees. Put in our calculators, it will be about 59.8. Now we're done with part A, so we can conclude that our x will be negative 27.9 and our y will be 59.8. Now let's move on to part B. If a second plane that's located at the location 50, negative 75. What are the polar coordinates given R, which is the radius have to be positive and the angle theta is between 0 and 360 degrees. And round our nearest mile, and then the degree to the nearest tenth of a degree. So let's begin with part B now. So let's start with the given 50, negative 75. So does it mean that x is 50 and y is negative 75? Now we are going to find the angle theta. We are going to use tangent, the inverse of tangent. So theta equal inverse tangent of y over x. So therefore we will substitute now to be inverse tangent. Substitute y for negative 75. Substitute x for 50. Put in our calculator for the degree mode. We will end up with negative 56.3 degrees. Now at the requirement right here we say that we want our angles have to be positive angle between 0 and 360. Then what we should do, the next step will be, sin theta have to be between 0 degree and 360 degree. Then what we should do with our negative 56.3 degrees, that we need to add 360 to find the positive coterminal. So take 360 plus negative 56.3 degrees, and that will give us 303.7 degrees. So now we have the angle theta. The next step, we just have to find R. So to find the radius, we only use the Pythagorean theorem. So R equals square root of x squared plus y squared. Now we will substitute x for 50, so square root of 50 squared. Substitute y for negative 75. Make sure you put your negative value inside the parenthesis and put the exponent. If you forgot to put the parenthesis and if you only put the exponent, then sometimes when you put in your calculator without thinking, your calculator will only square 75, not negative 75. So you have to be careful. Then the answer will be about 90 because we round to the nearest mile. So therefore we can conclude. So we can conclude right here. Let me just move the paper up a little bit. So we can conclude right here that if we know x, y, where x is 50 and y is negative 75, then our solution in polar coordinates. So then the polar coordinate for 50, negative 75 or 90, 303.7 degrees. Now let's move on to the last part, which is part C. On part C, we need to find the distance between the two planes. So let's find out the distance between. So let me write out the polar coordinates for each one. So for the first plane will be 66, 115 degrees, and the second plane is 90, 303.7 degrees. So to find the distance, you are going to use the distance formula. Let me use different letter. I'm going to call this as D. B equals square root of R1 square plus R2 square minus 2 times R1 times R2 times cosine of theta 2 minus theta 1. So let's go and substitute now. So these equal our R1 is 66, and put 66 inside the parentheses square R2 is 90. 90 squared minus 2 times 66 times 90 times cosine of 303.7 degrees minus 115 degrees. Put them in your calculator. Make sure you move in degrees. So our answer to the nearest mile will be 156 miles. Thank you so much for watching this video. I will see you in class. Goodbye.